In this video, I'll go over both learning targets MS5 and MS7 since they started on the same page. So MS5 first. Explain how solubility is a characteristic property used to identify substances. So it's helpful to think back to the other characteristic properties we've talked about this year. We've talked about density. We've talked about melting points. We've talked about boiling points. Whoa, that's not a word. You can tell Miss Bryn has been doing too many of these videos lately. Okay, boiling point. And the thing that all of these have in common is that no matter how much of a substance you have, the property stays the same. So for example, the density of water is 1 gram per milliliter. And that's true whether or not you have 5 milliliters of water or 100 milliliters of water or an entire bathtub of water. No matter what, the mass of 1 milliliter of water would always be 1 gram. Melting point and boiling point are similar in that for water, no matter how much water you have, water will always boil at 100 degrees Celsius, and that's true whether or not you're boiling just a cup of water or 10 cups of water. When that water reaches 100 degrees, the water will start to evaporate. Solubility is similar to these. No matter how much of a substance you have, the solubility is a ratio of the grams of solute. Sorry, pen's going crazy. Solute. It's a ratio of the grams of the solute that will dissolve in the volume of solvent. So no matter what, the solubility for a substance stays the same as long as you're not changing the temperature and funny things like that. So this question asks you to go back to table 1 on the previous page to identify why were you able to use the values in table 1 to identify one or more of Bryson and Alexis's mystery substance. So if we go back to that previous page, this is table 1. Some people tried to answer this question using these right here, and it was a little bit confusing. But you're able to use this because solubility is a characteristic property, and it doesn't change no matter how much of a substance you have. For MS7, predict the behavior of one or more substances based on solubility. So again, you refer back to table 1, which is the one that's at the bottom of the previous page. Which substance would Bryson and Alexis be able to dissolve the most of in water? Which substance would they be able to dissolve the least of? So instead of explaining this particular question, I'm going to give you a different example and let you solve this on your own. Let's say I have, and I'll write that this is just an example. Let's say I have substance Z, and I have substance Y. And let's say that substance Z, I can dissolve 16 grams of the solute per milliliter of solvent. Substance Y, I can dissolve 23 grams of solute into 1 milliliter of the solvent. Now, if we were to illustrate this, what this means is if this square, let's do a prettier version of this, if this square is to equal 1 milliliter, and let's just copy this so we have the same one on the other side. If we have a milliliter on either side of this situation, what this means is that I can fit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 grams of substance Z into 1 milliliter. This means that I can fit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 23 grams of substance Y into the same amount. So what this means is that I can fit more into 1 milliliter. So this is a more soluble substance. It's easier to split this one up in water before it becomes saturated and the water can't break it up anymore. This one, as soon as we get to 16 grams, the water can't dissolve it anymore and it starts to sink to the bottom. So this one is more soluble, and the bigger number is what helps you out with that problem. For the extension on this question, again, I won't go over this too much just because it was one of your homework questions, but what I will tell you is that people that answered this question a lot of times just talked about that we need to protect the animals, we need to protect the water. But what I want you to really emphasize it was why it's important to know the solubility of fertilizers that farmers put on their crops, and why that particular property is helpful to know for us.